Modernfold makes customizable wall partitions to meet customers' functionality and aesthetic needs. Pictured here are Modernfold's custom panels made for convention centers. Assembly of the panel is spread out through 5 stations, starting with initial assembly of the panel, welding and crimping the panel to secure assembly, applying fabric to both sides of the panel, and adding additional features for a completion of a high-quality product.
Before our current state analysis, the objectives we had set were improve the line throughput to 45 panels per day with an expected 10% growth within 3 years, increase the line capability to accommodate for 50-foot panels, and identify the most dangerous operator tasks with the intention of redesigning the process to improve working conditions. During our current state analysis, we conducted time studies, work sampling, and ergonomic assessments to better understand the process, determine cycle times, and identify waste. The time studies show that almost all operations were above takt time due to a lot of waste. The fabric station 2 was determined to be the bottleneck. The waste identified at this station was material handling, reworks, motion, and waiting on glue.
REBA is a quick, simple scoring assessment that indicates if an operator's job position will lead to musculoskeletal disorders when performed over a long period of time. During the current state analysis, any operator task that receives a score of 8 or higher is considered a high-risk job and needs immediate change. The tasks identified as high risk were moving the panels from station to station and using tools to assemble the panel.
Narrowing down our scope required us to modify our objectives. The goals of this project coming out of the CSA presentation were to improve the line in order to meet the current throughput and 10% growth, and also to automate the glue and covering application processes for at least 85% of products on this line. The main difference with the future state designs is that there will be an automated fabric and glue application line that will be able to service about 85% of panels.
This is an overhead view of the automated system. The panel starts at the welding and crimping station. It then moves to a table inverter. From there, the panel attaches to an overhead cable system and is guided by a ground rail system. The panel then goes through the automated application process. Once done, the panel is placed on another table inverter and sent to the next station. There are 3 types of material handling used in the automated system. Firstly, the table inverters. These are used to change the position of the panel from horizontal to vertical orientation. Next, the overhead cable system. This moves the panel through the automated line by cables that are attached to the top side of the panel. Lastly, the rail system. This is used to stabilize the panel while it's being transported by the cable system.
The new system will automatically apply hot melt glue to the fabric and immediately place the fabric onto the panel, followed by a roller that applies pressure to smooth out fabric and ensure adhesion. To confirm that our throughput objective would be met, our team simulated the assembly line in Simeo. It was found that the throughput would increase from an average of 11.6 panels per shift with the current state to an average of 46 panels per shift with the future state.
The combination and automation of the 2 fabric stations will make their new cycle time 10 minutes, which is below the takt time. The fabric stations will no longer be the bottlenecks of the line. The total lead time for a panel will decrease from 124.5 minutes to 75.5 minutes.
The left table shows the cost of the project. This includes overhead, equipment, and installation costs. The total cost comes out to be a little over $1,009,000. The right table shows the projected annual savings of the project. With increased throughput, reduced overtime, and reutilization of workers, Modernfold will save around $1,094,000 per year. The table shows the net present value of the project. The project will pay itself back in year 2. The current net present value of this 3-year project is $1.1 million.